Hi, and welcome to today's video. Today we are looking at order of operations, which is a great place for us to start. The reason for that is we have a particular order that we have to do math in. And the reason for that is math is a universal language. So if we are doing math here in Canada one way, and let's say over in Japan they're doing it a different way, we're going to arrive at different answers if we're not all on the same page and doing things similarly. So today we're going to look at the order that we will do things in terms of operations when we have algorithms like I have up here, and then we will look at each step and break them down as to why we do those things. So first things first, let's take a look at what we are actually looking at, and as you can see we are following the pattern of Bedmas, or you might refer to it as Pedmas or PEMDAS or whatever, and I'll explain what each of those are. So these are the orders in which we have to be able to go through and look at things mathematically. So B stands for brackets. We're going to do anything in brackets first. And you can see in our equation here that we have a set of square brackets and we also have a set of round brackets. So we have brackets within brackets, and those are called nested brackets. We'll get to those in just a second. The second thing we have are exponents. Exponents, in case you are unfamiliar with that, what an exponent is when you take a base number, let's say it's 3 to the power of 3, or it's 3 with an exponent 3, we are multiplying the base number, the base number, by itself this many times. So if I broke this down, it would be 3 times 3 times 3. Now a lot of kids get that confused where they think that this is 3 times 3. And if that was the case, we would just simply write it as 3 times 3 in math. But this exponent means multiply the base number by itself a certain number of times. So I have 3 3's, and that's where that comes from. Okay? Now, as you can see in our equation right here, there is no exponent that we're going to be working with today. But this is a good kind of refresher when you're thinking about exponents. Now the next ones are division and multiplication, and these two are kind of important because division and multiplication are done in the order that they appear from left to right. So if you see a multiplication first, it means that you're going to do the multiplication first in this. If you see a division first, it means you'll do the division first in this after you're finished looking at brackets and exponents. And the same thing goes for addition and subtraction. When we are looking at addition and subtraction, they are done in the same order as well, from left to right in the order that they appear. So now that we've taken a look at what Bedmas is and what it stands for, let's actually break down this equation. Now, I mentioned earlier that we have a nested bracket, and a nested bracket means that we have a bracket within a bracket. So if we follow the order of Bedmas, brackets will come first, and you can see that there are a couple of different things happening here. I have a subtraction, and I have a multiplication, and I have a bracket. So there are 3 things that are happening within this bracket. Now, working just within the bracket, because that's what comes first, we have to look at, if I go to order again, there's a bracket inside, so I have to do what's inside the bracket first before I can do the subtraction. So let's do that. I'm going to keep this bracket because it kind of matters. So I'm going to keep the square bracket. 8 times 3 gives me 24. And I'll tell you why I'm going to keep this in just one second. 24, and then I have minus 2. And then I didn't do anything with this right here. So I'm just going to bring it down. Plus 10 divided by 5. And that way I'm just going to continually move down and do one step at a time. Now you might be thinking to yourself, okay, in step number 2 there is no longer a nested bracket. Well, why is that? Well, that's because we no longer need a nested bracket, because the number 8 times 3 was 24 and it only gave us one number. So there's no reason to have that second bracket inside of there because it's just a single number that's left. So there's no operation that's actually happening at all, leaving us with what we didn't use, the minus 2. Now, I kept the square bracket outside to remind myself that this was within a bracket to start. That way it doesn't confuse me and I don't come all the way over here to do division next. So, going back to Bedmas again, I'm on step number 2. I go back to the beginning of my list. Here I am with a B, the brackets. There is a bracket and I have to do what's within it first. So in this case, I have 24 minus 2. Now you're going to notice I'm going to get rid of the bracket again altogether because once again, there's only one number. There's no operation happening within there. So I can actually get rid of it and then bring down again what I didn't use. So that's plus 10 I didn't use, and I divided by 5. Now if I go back again to my list, I'm looking at B for bracket. There is no bracket here any longer. E, there is no exponent here. Then I have D and M. I'm looking for division and multiplication. And as you can see, I have an addition, but I also have a division. So there are two operations. Division will have to come first. So I'm not going to do anything with my 22 to start. And I'm going to take 10 and divide it by 5. Well, 10, if I take that and split it into groups of 5, I get 2. So I'm going to have 10 plus 2. 10 divided by 5 is 2, and it's positive, so I'm left with this. Now, if I go back once again, you can see I only have one step left to do. There is no bracket, there is no exponent, there is no division or multiplication any longer, and there's just an addition left. All I have to do is simply add these two numbers, and I've come to the end of my equation.